Welcome. My name is Roy DeRocha. I'm the Sensory Practice Leader in UVM Extension's Northwest Crops and Soils program. I work under Dr. Heather Darby, who is the head of our group within UVM Extension. I'm a sensory expert with a little over 40 years of experience working with companies around the world in the issues of sensory analysis, both on the descriptive side and on the hedonic side, as well as innovative consumer insight methodologies. And my formal background is in chemistry. Started out as a flavor chemist and have brought that to the party with all of the descriptive sensory work and consumer work that I do. Although, as you will see in the overall program here, we go well beyond just talking about those issues in connecting the dots to attributes that lead to success. Now, I also wear several hats on the overall program here. And this is the sensory-directed approach to understanding artisan cheese, as was on our title slide at the beginning of this webinar. And some of those hats beyond this subject that I'll be speaking about in this webinar include sensory training or knowledge transfer, where I have been spending time with our partner cheesemakers, Jasper Hill Farms and Springbrook Farms. You can see some photographs on the bottom of some of that training where I'm teaching them a bit about objective descriptive sensory so that they can apply some of the concepts and some of the measurements that we're making in this program to their businesses. I also have been integrated into the chemistry component of this program, and you can see a picture there of me sniffing from an odor detection port, which is hooked up to a GC mass spec. And basically, I'm sniffing to see if I smell compounds coming off the instrument, and then seeing if the instrument can identify those compounds so we can get further insights into where aroma and flavor is coming from that the end consumer reacts to. Now, this program overall is called a sensory-directed approach to understanding artisan cheese. And what does that mean, a sensory-directed approach? Well, for us, it means linking critical information to discover what drives success in the market for artisan cheese. And so during the program, we're collecting lots of data. First of all, it starts at the cheese manufacturing facilities at Jasper Hill and at Springbrook Farm, and we're collecting data on what happens there in the process with the cheese. The second component that I will be talking about today in this webinar is descriptive sensory analysis. And what that means is using a highly trained panel, in this case at UVM Extension, to objectively measure the aroma, flavor, texture of artisan cheese to give us an objective database to correlate against other objective measurements and subjective measurements to connect the dots to figure out what causes certain aromas and flavors and whether or not those aromas and flavors are liked by the end user and will drive up consumption and purchase and success in the market. So this webinar, I'll be talking about the descriptive sensory analysis or the trained panel result of the study. There's another piece of the study that there is a webinar available on microbiology that was done by Dr. Ben Wolf at Tufts University. We have chemical analysis that was done. I showed you the picture that was done at Tufts University. There's healthy fatty acid analysis that was done by one of my colleagues at the University of Vermont. And then there's some subjective information where we have done some hedonic testing ourselves using these cheeses, and I'll be reporting on that data and the linkage to that data in subsequent webinars as part of this series. But for today's session, I want to focus on the objective trained panel result, the thing that we call descriptive sensory analysis. And to give you a little bit of background on what we mean and what I mean by descriptive sensory analysis, I'm talking specifically about the original methodology, the flavor profile method that was developed by Arthur D. Little in Cambridge, Massachusetts, in response to an ingredient company wanting to describe in terms that companies could understand the total sensory effect of aroma and flavor, both quantitative and qualitative. And it was called the flavor profile method. And rather than it being subjective and saying, I like this, I don't like this, this is good or bad, it was the world's first attempt to describe in detail what things smell like, what things taste like, and how much. Now, a little bit later in the 1970s, Arthur D. Little realized that they could modify the method to generate a very efficient score sheet approach. And that score sheet approach became known as profile attribute analysis. Profile attribute analysis is the method that you will see in this webinar that we used to develop the objective database that we are correlating against all the other measurements in the study, and to define our learnings for the objective tasting of these cheeses. In the early 1980s, Arthur D. Little took another step that's important to us in this webinar, and that was the establishment of what's called the flavor leadership criteria. This was a point where Arthur D. Little realized that many of the market-leading products in the food industry had things in common. And they did a study, and they found out that all market-leading products had 5 things in common, and they termed them the flavor leadership criteria. The flavor leadership criteria are a powerful interpretive method for allowing us to predict what consumer reaction is going to be to certain aroma and flavor. And it's critical for us, and in this study it was critical for us, to take into account flavor leadership criteria when we design the score sheet that we would be using to taste the cheese, knowing that we're going to correlate that against the hedonic information, consumer overall liking, preference, and other hedonic measurements later in the study. And the last point I would put down here as far as background is that I actually spent almost 20 years of my career, the first 20 years, at Arthur D. Little, learning from the pioneers of these very powerful methodologies, gaining experience in how to apply them and use them, and even more important, how to interpret the data that gets generated when we use these very powerful methodologies. Descriptive sensory analysis. Really, it's using people as instruments to objectively measure what things smell like, taste like, feel like, and how strong. That's what descriptive sensory analysis is. Now, when I came on board at UVM Extension about 3 years ago, the first thing I did was train a group of staff in UVM Extension. They are in the Northwest Crops and Soils program, including our leader, Dr. Heather Darby, in these original methods, and give them experience in applying them to a range of products that are important to us, especially here in Vermont. The panelists who I trained within our group are located in 2 locations. They're located up in our main office in St. Albans. They also are located on campus in Burlington at the Jeffords building. And all of the panelists that I trained attended extra training. We call it sensory orientation, where we look at a much broader range of artisan cheese products to really understand the range in flavor and the different attributes and the level of those different attributes that an average consumer would be exposed to. This experience, this thing called a sensory orientation, was critical for us to do in order to develop the score sheet that we would use in this study. And so we had a lot of training using reference standards back and forth, and then using lots of samples from the market to get ready to complete this study. Now, I want to talk about the flavor leadership criteria because, as I said, it is a very powerful interpretive tool, which means it's also very important to consider upfront when we're designing our score sheets, because we want to make sure at a minimum that we're collecting information that relates to the flavor leadership criteria. And so what are those flavor leadership criteria that Arthur D. Little developed that define success in the market, which another way of saying is produces things that people like to eat and consume on a regular basis? The first one is called aromatic identity. It's pretty straightforward. It means when you put a piece of cheese in your mouth, it should taste like cheese right away. It doesn't have a flavor lag. You get what you expect early on. It should have a certain amplitude, and amplitude is a complex measurement for us as a trained panel. It's really divided into 2 measurements. One is called fullness or richness of flavor, and that's a function of how complex does the cheese taste. The other one, balance of flavor or harmony. The third criteria is mouthfeel, compatible mouthfeel. You know, it's okay to have some sting if you're eating mustard, but you don't want sting and irritation if you're eating cheese. Off notes, there shouldn't be any flavor or aroma in the product that the consumer doesn't expect to be in the profile of that product. So if we're tasting cheese, we shouldn't have soapy, we shouldn't have Barney, we shouldn't have certain things that consumers don't expect to be there. And then aftertaste, counterintuitive to what some people think when we deal with artisan products. Some people would think artisan products, longer flavor is better because people enjoy the flavor, they want it to last. What we see in the market is people want the flavor they expect. They want it to disappear relatively quickly so they can eat more and enjoy more of it. And so these are the 5 flavor leadership criteria that we take into account. So what we did as a panel, we used our train group at UVM. We screened a wide range of cheeses. We had discussions around what specific attributes or characteristics in aroma and flavor were varying and caused differences in the cheeses in the market. And then we developed a score sheet to represent those things that we saw were differentiating or varying between the different cheese products. And you can see here that we've also incorporated the flavor leadership criteria. So here is a standard profile attribute analysis score sheet. Each horizontal line is a specific aroma or flavor attribute that we want to measure. Aroma, we're measuring total intensity of aroma only, which goes from none to strong. What is the intensity of the cheese when we smell it? Now, we also have words on what we smelled. That's not in this presentation, but we have all of that level of detail that we're using in our correlations as well. And then we get into the flavor. We talk about balance and fullness, which is the harmony and the complexity. We work our way down here, total intensity of flavor. So when you put it in your mouth, how strong does the cheese taste? And that's a combination of basic taste, sweet, sour, salty, bitter, and umami, aromatics, cheese aromatics, as well as mouthfeels. And then we break things out. We're looking at fatty acid taste, which is butyric buttery, as a separate attribute. We have another fatty acid cheese taste that we describe as isovaleric or sweaty or stinky cheese. We have a savory taste like mushroom or something that might have MSG. Sulfidey, this is things like onion, garlic, kinds of spicy notes that we might get in the cheese. Ammonia, of course, may be coming from the rind. Brininess, which is the, barniness, which sometimes we get with cheeses coming from the milk, coming from other sources. As these things age, we get musty notes, earthy notes, moldy notes. I think we see some of this with the Harbison that we use in the study. As cheese ages and gets mature, we see oxidation notes, things like nuttiness and woody. We see green notes, grass, hay. In our study, we'll see elevated green notes in one particular sample because it is in contact with an aromatic wood. We measure sweet on the tongue, sour, salty, and umami, all on the tongue. Dairy intensity as a standalone number. Mouthfeel, others, and aftertaste. And we're using a standard 7-point scale. Lots of sensory groups use different scales. This is the original Arthur D. Little scale that was developed for flavor profile. It came out of work that was done at MIT down in Cambridge, Massachusetts. How many levels of intensity can an average customer consistently differentiate? The answer was 7. So they developed a scale that goes from none to slight to moderate to strong with points in between to represent the level or the intensity of each of these key attributes that we were going to measure in the study. We also did some texture notes. We had firmness, crumbly, and particulate. The difference between mouthfeel and texture is when we describe the cheese. So if the cheese was firm or soft, if the cheese was crumbly or not crumbly, does the cheese seem like it has particulates in it or not? Anytime we describe the cheese, we're talking texture. If we describe how the mouth feels, my mouth is dry, my mouth has a coating, then that's a mouthfeel and it gets recorded on a previous slide, a different part of the sheet that we're using. We decided to use 6 different brands of cheese. There's a note on this slide that we need to keep in mind as I go through these results that our study is not designed to take a deep dive into defining what each of these brands of cheese tastes like and smells like and what their variability is over time. Our objective in the overall study is to use 6 cheeses that we think are different in flavor, at least different on key attributes, that when we present them to consumers to get their reaction to what they like or don't like, we can link it to the specific attributes that these cheeses represent. So we'll keep that in mind, because as we go through and we get to some of the results, I'm not going to report these as, well, here's the result for alpha Toman, here's the result for Harbison. You'll hear some of that. What I will be reporting is, in the group of 6 cheeses, here's how this attribute ranged, and here's how this attribute ranged, because that's the data we need, and we need ranges to be successful at correlating against consumer overall liking to figure out what drives that overall liking, either up or down. So keep in mind that as we go through these results, we are mentioning the brands. From Jasper Hill, we used Harbison, Whitney, and Alfred Toman. And from the other farm, Springbrook, we had Redding, Ashbrook, and Tarentaise. So we had 6 cheeses that we felt represented a big enough range of flavor. Certainly not the whole range of flavor that we have in the artisan cheese category, but a big enough range that we can begin to understand what's driving differences in aroma and flavor, what's driving a certain smell that you're getting, or a certain taste. Is it the microbiology? Is it how it was processed? Is it something else? Was it the milk? Was it, is it because of the healthy fats versus non-healthy fats? So we needed ranges of things to meet our overall objectives. Now, for our panel design, we decided to do a snapshot in time. So we do have data. It's a separate part of the project I'm not reporting on in this webinar. It would take way too long. We did do monthly tasting of these cheeses. We did monthly tasting of some of the milks. We have an incredible amount of data to use to help support our findings, and also give the cheese makers more information about consistency month to month and season to season and all that. But for the purposes of this webinar and the bigger objective of the study, we decided to pick a snapshot in time, and that snapshot was August of 2022. And we decided to select the 6 samples that I just showed you, 3 from Jasper Hill, 3 from Springbrook Farm. And we decided to use good science. So for each batch of cheese, we selected 3 lots or wheels of that cheese to give us some sense of, was there variation within a batch. You'll notice later that for the Harbison, which comes in very small wheels, we actually had to use 6 of those wheels instead of 3, but the concept was the same. We're still using multiple lots to do good science. We also did 3 panel replications of each condition. So we had 18 total samples. If you take 6 samples times 3 wheels, that's our 18 samples. And now we're going to do 3 replications using our trained panel of each of those conditions. And of course, the samples were presented blind random order. We didn't know what the samples were when we actually assessed them on panel. And just for background, I was one of the panelists, an equal panelist. We're all equal once we're trained on these profile attribute analysis panels. So now what I'd like to do is go into a little bit about what did we find. We did a lot of tasting. That's a lot of tasting to do for profile attribute analysis. But now what we do is we take the average score for each attribute that was measured, and we summarize it, and we look for differences. So this chart is one of hundreds of charts that we have on this program. This is a summary chart, a top-level chart, where we're combining data for each of the types of cheeses. You notice on the left, we've got Alfred Toman and Ashbrook and Harbison going down the list. And we are averaging the data for all 3 lots or 3 wheels to get a sense of, in the big picture, what kind of differences are we looking at. Now, a key point to understanding this data is that we're not just looking for statistically significant differences. They're important. And yes, we do those statistics and we want to know what's statistically significantly different. But for us to be successful in the bigger picture, to make relations, we need to make sure that the differences are not just statistically significant, but they're big enough that the average person who's eating this cheese not only notices that difference, but cares about the level of difference. It drives their emotion. Either it makes them like the cheese more, or it makes them not like the cheese as much. Now, we've done thousands and thousands of these studies around the world, and what we see all the time, cross categories, is when we look at these panel averages, if we see values that are 0.5 units or more different from each other, then there's a very good chance that's a meaningful difference. Meaning if we go and test it with a customer, they not only will notice that difference, but if you ask them to score how much they like the sample, it will have an effect on their score. And this is a nice rule of thumb for us to use in research to begin to understand if we've got a set of samples that's going to give us a chance to connect the dots in the end. And as I go through this, you'll notice that for each of the attributes, and again, I'm not focusing on which attribute belongs to which cheese. You can do that. You can get our report and look through and see what each cheese scored and what the profile of that cheese was. But for the sake of what we need to do in this segment of the study, we need to make sure that we have meaningful differences represented in our sample set for each of these key attributes. So for example, if we look at balance of flavor, you'll notice that all of the green scores, by the way, are the low score in the set, the low average score as measured by our objective panel. And the one highlighted red is the high score. So we'll just look at the highs and the lows to see if we've met our requirement for having meaningful differences. And you'll notice that the Tarentaise scored a 2.8 and the Ashbrook scored a 4.2. Higher numbers are more blended, more harmony. Now, I'm going to tell you in a few minutes that we had some issues around that Tarentaise. It was a unique sample. Unfortunately, we've seen it many months, and the one that we had in August, something happened to it. So that one's going to fall out of the mixture. It actually is a good sample for us in the sense that it helped to stretch some of the dimensions that we're trying to figure out, but it's not indicative of what Tarentaise normally tastes like. But going back to our discussion of needing a range, you'll notice the Tarentaise scored a 2.8 and that Ashbrook scored a 4.2. That's more than 0.5 units. So we now have at least two samples in the set that will give us a meaningful difference on that attribute that we can now collect overall liking data on and do some correlations with that data. You'll notice on fullness of flavor, we go from 4.2s up to 4.8s. So we've got a 0.6 unit. We look at the two types of fatty acid, buttery cheese, which is the butyric and isovaleric. We notice on the isovaleric, we go from 2.7 to 3.6. And we go down this list. We can see the savory note, which is kind of the mushroom note. We go from a 2.5, the harbison being up around a 3.3, and so on and so on. Now, if we want to, we can create a smaller comparison and look at those flavor leadership criteria. And that's something that we focus on heavily. We want to see differences in all those attributes because when we did the sensory orientation, they all seem to be important. But at a minimum, we want to see ranges on the things we measured that relate to flavor leadership criteria. And again, you'll notice we certainly did it on balance. And all the way across the board, even when we get down to aftertaste, where the low score is a 4.0 and the high is a 4.7. On others, we go above a 4. So we're down 2.8 all the way above a 4. So we have a lot of confidence in the sensory results of the panel that we've got good ranges of meaningful differences using this set of 6 cheeses. Now, the next thing we want to do is see, okay, when we take a higher level look at this and we try to create some summary indices, what is it going to look like? And this is a very powerful way to look at descriptive sensory data. We look at the detail, we look at an attribute level. We absolutely do that, and we're going to break it down and we look at the different wheels and the different cheeses. But then we want to know that, all right, but if we start combining some of those individual attributes, are there certain combinations of attributes further explain differences from the samples, which in fact helps us understand differences in the market that the customer sees? And a common way to do that is some form of cluster analysis. We very often will do principal components analysis. The sensory people that are listening in will understand this clearly. And what principal components analysis does is it takes all those data points that our panel generates for each of the attributes, puts it into a program, and it says, okay, which group of attributes, if we put them together, gives us most of the differences in the sample? And it's never 100%, but it'll be 30, 40, 50% of the differences. And then the program will say, okay, now let's look at them differently. Let's regroup all those attributes. What group of attributes would give us additional differentiating information? And it becomes another dimension. And then it will do a third and a fourth and a fifth. And each time you add a dimension, it gives you more percentage of the difference that you're accounting for. So one dimension might account for 40% of the differences. And then if you combine one dimension and you add a second dimension, you might get up to 50%. So what we found in this study was that when we looked at the data, and this is pretty common for dairy products, we had 3 eigenvectors, or 3 principal components that came out of the analysis that helped to describe most of the differences in the samples or between the samples in the set. The first of those and the most powerful component, we're going to put a label on. It's just a label. We're going to call it richness of flavor. Now, you can see richness of flavor here. Lower scores are less grassy, less sulfide, less isovaleric, thinner in flavor, not as complex. When you get higher scores on this first component, we get more of those things, more green, more sulfide, more umami, richer flavor, meaning more complex. Now, for the technical people out there, the way this happens is the principal components will generate weighting factors for each attribute, and then the program will multiply those weighting factors times the panel average scores and come up with a single number representing that index. And then we can plot that number in a few minutes. So first index we got was called richness of flavor. The second index, we're going to put a label on it and call cleanness. Some people like to use the word quality. Sometimes we do. But quality really has to take into account not just cleanness, but the identity of the product as well. Things like richness, things like cheese type that you're going to hear about in a minute. So we're going to put a label on this particular component, and we're going to call it cleanness. And higher numbers are cleaner. So if we think about the flavor leadership criteria, higher numbers mean more acceptable to consumers or more liked because they're cleaner. They have less others. They have less aftertaste. And remember those flavor leadership criteria. So the second dimension we had, we're going to call cleanness. Higher numbers are cleaner. Lower numbers are not as clean. And we're going to see some of that data in a minute. And then the third one, and this does correlate a bit to the first index of richness. We're going to call it cheese type. And the reason we're going to call it cheese type, it's a very interesting dimension that came out of this particular set of samples, where lower numbers are the ones that are more commonly known as stinky cheese. So lower numbers have more isovaleric acid notes, more sweaty notes, more stinky cheese notes, and less of the buttery typical cheese taste. Higher numbers are more like buttery cheese. They don't have as much of that sweaty, the dirty sock, the stinky cheese notes. They're lower in that, but they have more of the kind of buttery dairy characteristics that we see with other cheeses. So these are our 3 summary indices. And now what we can do to illustrate differences and understand what our sample set represents in the big picture, we can develop what are called flavor maps. Very often we'll do 2-dimensional flavor maps. They're easier to understand. This is the first one that I'll present as part of this webinar. And in this one, we're looking at the richness of flavor versus the cleanness of flavor. And the first thing you'll notice is this dot way to the left on the x-axis, which is cleanness. Remember, higher numbers are more clean, lower numbers are less clean. Higher numbers that more clean because they have less others, they have less aftertaste, they have less mouthfeel, all of those important flavor leadership criteria. Lower number is less clean because it had more off notes, more aftertaste, more mouthfeel. And again, that's that Tarentase sample that we think something happened to the particular wheels that we ended up using in the study. So we're going to include it in it because it stretches our maps, but we wouldn't read much into associating that place on the map with what that cheese normally tastes like from Springbrook Farms. I mean, it normally is somewhere else on this map. You'll notice on the richness that we have some separation. We have Harbison way up the top here. So the flavor that Harbison represents occupies a unique place on this map. Alfred Toman and Whitney occupy a place on this map, and Reading and Ashbrook, at least on the richness scale, and to some degree on the x-axis, occupy a unique place on this map. Now, when we read these maps, typically we are still looking at that 0.5 or more units as being meaningful. We do that for average scores from the panel. We also do it for these summary indices. But in the end, we really do need to get some consumer data to confirm some of these things, which is what we're doing in the overall study, and I'll be presenting in a separate webinar. So we see some really interesting things here, as if we discount this one over here, you know, we see the Jasper Hill cheeses performing a certain place on the map. We see the Springbrook farm cheeses falling somewhere on the map. And I'll jump ahead to a different seminar, but when we start to connect the dots, one of the things that we saw in this study is that the microbiological profiles of these cheeses actually make sense when you look at their sensory location on the maps, telling us that microbiology certainly is one of the drivers of where these are on the maps. And that we kind of expected, but we know a lot more now about, you know, what that means and what those microbes are. If we look at a different map, we can look at richness versus cheese type. And this is the one I said that it does correlate a bit, not a great correlation. But there are two different things at play here. The richness index itself, which is the Y index, really takes into account overall complexity. And that's why you see the Harbison way up here. And you see the Tarentase in here, and you see the Alfred Toman here. You see these scoring, we would expect them to score higher up on complexity. When we go to the right on this map on the x-axis or to the left, this is where we're defining what we call the fatty acid character or the cheese character. Is it more buttery? Is it more sweaty, footy? You know, where does it fall in that continuum? But also a heavy influence from the savoriness and the mustiness. And that's why Harbison falls in this unique position, because Harbison, which if those of you out there don't know, is unique in this sample set in that it's a bloomy rind cheese. It also has a small sleeve of a very aromatic wood, I believe it's spruce, that goes around the outside that allows flavor migration into the wood, but more importantly, the woody notes get into the cheese. And it adds an awful lot of complexity and savoriness to the cheese. And so that's one of the reasons why that sample gives us a sensory profile that falls in a unique place on our sensory map. And again, that is a good thing. We want to span things on the sensory map because we're going to then go and check with consumers, what do they like and not like on these maps? And then we're going to connect it and figure out, okay, how did the points get there? What were the factors that drove it to be at that particular place on the map? Now, we did have another very powerful piece of this program, which, as I mentioned earlier, is that we did multiple lots of cheese. And with each of the individual lots of cheese, or more correctly, wheels of cheese within the batch, we did all of the independent testing. So for each wheel of Alfred Toman, for each wheel of Whitney, for each wheel of Reading, we cut pieces of those wheels and sent them for microbiology analysis, chemical analysis, fats analysis, descriptive sensory, all of the components of the study that I showed you on the first slide. And so if there were differences between the wheels, we have an opportunity to perhaps understand why. What else was different? Was the microbiology different between the wheels? Was the chemistry different between the wheels? Well, in this section where we're talking about the descriptive information only, where we can answer the question, were there meaningful differences between the wheels or the batches, the different lots within a batch in August of 2022, this flavor map tells us yes. It tells us that there weren't huge differences, but that there were differences that by our definition would be meaningful, meaning they'd be big enough that the average person would notice that difference and would care about it. So even the Tarantes over here on the left that we said we had some issues with, when we look at the three wheels, and each point represents a lot or a wheel of cheese on these two indices, sensory indices, richness and cleanness, we can see that we've got more than a 0.5 unit difference between some of these samples and this one over here. So the circle here is big enough that it tells us within that batch, there, depending which wheel you got your sample of cheese from, we expect that there would be differences that the average consumer would notice and care about. You notice the Harbison. The Harbison is the red one here, and we've got, remember, we had 5, 6 wheels of Harbison. That span not only the cleanness index, but you can see it also varies on the richness index. And that's no surprise to us. Harbison is a very complex cheese. It's a very complex flavor system, and it has that added flavor mechanism because it's wrapped in that piece of wood that allows migration both from the wood into the cheese and vice versa, that we might see variation in the flavor of that small wheel, and it could differ wheel to wheel depending how the migration happened from wheel to wheel. So we saw that, and it's something we expected. It's, again, a good thing because we've got data on the individual wheels of cheese that we can go back and look at. Now, the other ones down here, you can look on this map. The same holds true for the Whitney, the Reading, the Ashbrook. Pretty much every cheese we had in this study, we saw some meaningful differences wheel to wheel. And it's less important for us at this point to clearly discuss all of those differences. It's more important for us to know what those differences are in our data so that we can now go and correlate and try to figure out what caused those differences. And that is certainly something that we're going to be able to do based on the data that we have here. So what did we learn in the descriptive sensory analysis piece of this overall project? First of all, we learned that there are meaningful differences in aroma and flavor between the cheese samples that we selected for this study, and in fact, more exciting, that some of those differences, those meaningful differences, are on key attributes that are known to drive consumer preference up or down. Things like balance of flavor, mouthfeel, off notes, and aftertaste. And so that's one very, very strong finding and very important for us to be successful in the bigger study. It's also important for the cheesemakers to even know this. I mean, some of it they know already, some they guess at, but this actually puts more data around and more detail for them. They'll get all the data we have in the study, but it puts more detail around, okay, well, how are those things, and which of the cheeses that they made were more blended, which were less blended, which had more aftertaste. They can look at the data and understand things that they care about as a cheese manufacturer. For this study, it's important for us to know, independent of what the brand was, that we had big differences, and big enough differences that it would matter to the people that we're about to test the cheese with. So that was the first finding in our study on the descriptive side. The second one is not a surprise, but we need to confirm it in every sensory study that we do, and that's that we do have summary indices that help us understand the overall differences between the samples that we're testing that hopefully represent differences out there in the real market. And as I mentioned during this presentation, the first two we see all the time. Doesn't matter what country you go to, there is always one dimension that we call product identity or richness or robustness. There is always a dimension that we call cleanness that differentiates things in the market, usually the market leader from people that are not the market leader. And it makes sense to us because it's driven by those flavor leadership criteria that make up all of these sensory attributes that our panel is measuring. In this case, we have a third one, which we think is going to be extremely helpful when we get to understanding the cheese users, especially when it comes to segmentation down the line and understanding a mainstream cheese user versus someone that really focuses on artisan cheese and what do they want. and the consumer in the middle that wants to do both. And that is really getting into more about, okay, but beyond the core drivers of richness and fullness and complexity and how clean it is, what about the cheese type itself, whether it's stinky cheese versus, a cheddar or something that's more buttery or mature tasting and not as stinky footy. And this other dimension that we have is going to help us to correlate and begin to understand some of those more complex issues with segmentation when it gets to the consumer side. But for the sake of this section, we can come to a very strong conclusion that these three flavor indices, complexity and richness, cleanness, or quality, you could even call it, and cheese type, help us to explain the majority of the differences in flavor that the average customer is going to see when they buy an artisan cheese. And then the other thing that we learned for the cheesemakers, but also for us going forward and connecting the dots in subsequent webinars, we did see meaningful differences between wheels of cheese within a batch of cheese. So whether it was the Alpha Toman, the Whitney, the Harbison, it doesn't matter which of the 6 cheeses we included in the study. When we look at the 3 lots that we collected within the batch in August of 2022, we did find meaningful differences on these critical aroma and flavor attributes. And because we collected data on those cheeses and generated objective data on the same wheels of cheese, so we generated the microbiology, the chemistry, everything else, we will be able to correlate and maybe gain some critical insights into where the flavor's coming from, where the aroma's coming from, ultimately be able to engineer things in or out, potentiate things, create products that even meet what the consumers tell us they like and don't like even more. So this was the third key learning from our descriptive analysis piece of the project. And so with all of that, we now get to a point where we are very comfortable, and you'll see it in some of the other webinars. You certainly will see it in the final report that we will be submitting later this month to our funder later in August of 2023. That in our detailed report, we're able to start to make some sense of all this, that we can take this objective sensory data and these flavor maps and these differences on these key attributes, and we can begin to look for correlations with the microbiology results, with our healthy fats analysis results, with chemistry results, with lots of other objective data to begin to understand what drives quality as defined by the consumer. And then ultimately, we're going to connect all these dots. It's not on this slide, but we're going to connect all the dots to the results from our consumer testing. Because one big piece of this project is taking these cheese samples and testing with cheese users to get their impressions of which ones they like and don't like and how much. And once we have that data, then we can answer the question, so what? As we figure out, okay, this microbe forms this flavor, we can now answer, okay, so what? Is that good or is that bad? Is that something the customer wants? Is it something they don't want? So we'll be able to do that using this database from the descriptive sensory analysis panel. It's this whole sensory directed approach is an extremely powerful approach. It's been used to develop many of the market leading products that you'll see in the grocery store. This is the first time, one of the first times we're using it to actually go back in the value chain and try to connect the dots to the farm, to the cheesemaker, to understand what they can control and what they can do to engineer products to better meet the needs of the end consumer. And hopefully, if we're successful at all of that, to grow the markets, increase the market, so that cheese consumers are happier, producers are happier, farmers who provide the milk are happier. Everybody benefits from higher quality cheese. I want to thank you very much for listening to this segment where we're focusing on the trained panel and how we use the trained panel in this overall project, what we're using the data for, and what's to come in some of the other webinars. I hope you enjoyed it. You can reach out to us at any time at the University of Vermont Extension for additional information. I hope you have time and interest to watch some of the other webinars in this series. And if you want more in-depth information about the stuff that I presented in this webinar or any of these webinars, you can access the final report through the New England Northeast Dairy Business Innovation Center. And we will be posting on our website once this is all tied up, how to access all of that information. So thank you very much for joining me. I hope you have a great day.